This is the dehydration of sucrose. I'm Elizabeth Fridge.
And I'm Sid Parker.
So everything has already been pre-measured, but you will need about 1/3 of a 250 milliliter beaker full of sugar, 50 milliliters of sulfuric acid. You'll need an additional 250 milliliter beaker. You'll need a sturdy stirring rod, a baking pan, and a chromatic heating pad. The baking pan will go on top of the heating pad, and then you'll place the 250 milliliter beaker inside. Before we begin, I do need to warn you that sulfuric acid is a corrosive substance. You'll need goggles, apron, and gloves to ensure that nothing spills on you. But in the event that something does spill on you, you will need to jump in the shower and tell the professor immediately. In addition, you will also need to tie your hair back if you have long hair and wear long pants.
Alright, so first we're going to start with our 1/3 250 milliliter beaker of sugar, and we're going to pour it into the other beaker. Then we're going to go ahead and take our 50 milliliters of concentrated sulfuric acid and pour it into the beaker full of sugar. Using the sturdy stirring rod, we're going to go ahead and mix the two substances together. So after the mixture is nice and mixed, we're going to go ahead and rinse our sturdy stirring rod in the sink. And so there's about a 1-minute delay before our reaction really starts to get going. So I'm going to go ahead and tell you about a French chemist in the 1800s. He wanted to return the carbon and water back into sugar. So he tried to mix charcoal, water, and a couple different catalysts together to try to get these results. But as ChemPub explains, he was a little unsuccessful. To this day, however, they're still called carbohydrates, originally used to describe compounds that were literally the hydrates of carbon because they had the empirical formula CH2O, but they're still called so despite it not really being a fitting title. In recent years, however, carbohydrates have been classified on the basis of their structures, not their formulas. They are now defined as polyhydroxyaldehydes and ketones. Among the compounds to belong to this family are cellulose, starch, glucose, and glycogen, and most sugars. Alright, so Elizabeth, using the sturdy stirring rod, is going to go ahead and help guide our carbon or dehydrated sucrose as it starts to rise out of the beaker, making sure it doesn't topple over.
And if you want to note the steam that's coming out right now, that'll come into play later.
So after our experiment has finished up, we're also going to go ahead and make sure it finds the proper waste container. Alright, so the results. Because sucrose is a disaccharide, when sulfuric acid is added, hydrolysis occurs and our disaccharide is broken down into fructose and glucose. And as Baker C. from Education and Chemistry further goes into detail, dehydration also occurs and produces a complex carbon solid. It's the mistake that pops out. It's this complex carbon solid thing.
Yeah.
Solid.
Okay, so during this experiment, the sugar is broken down into its 3 barest essentials: carbon, hydrogen, and oxygen. As Helmstein explains, when sugar is dehydrated, it's broken down into carbon, which is the solid black substance that appears, in water, which is boiled out, and it's observed as a gas or steam. And we observed that before and during the emergence of the solid carbon. The water is boiled because this is an exothermic reaction, which means that the energy is released. And on paper, our reaction looks like this. So it goes from a solid C12H22O11 to a solid carbon and a gaseous H2O. So how do we apply this to real life, or how does this apply to our real lives? In our bodies, the sugar that is broken down is not quite as exothermic, or else it would melt our stomach lining. But it still has many similarities. So according to healthline.com, digestive systems break down sucrose in small little almost groups using enzymes. And the small groups still produce a small exothermic reaction because, like I said before, one big exothermic reaction would cause our stomachs to melt. And during the digestion of sucrose, it is a disaccharide, and it's broken down into two monosaccharides, fructose and glucose. And disaccharide means that it's a sugar made up of monomers that can be broken down into two different monomers. The sulfuric acid in this experiment represents our saliva or stomach acid breaking down the sugar, but in this experiment it breaks it down into carbon, hydrogen, and oxygen. The digestive system breaks down the sucrose using hydrolysis, and that is the same process that was used in this experiment.
Alright, so I'd also like to point out the steam that you saw earlier. That was the sugar being stripped of water. This steam causes the remaining carbon atoms to expand into the black column. And this experiment also shows how black charcoal is rudimentally made by having large amounts of carbon atoms together. And though it's not really the charcoal you might throw on the grill, as Revolvi.com explains, it's a free reactive carbon that lacks any crystalline structures. So this experiment basically showcases a common chemical reaction that is the breaking down of sugar into other substances.
Thank you.